Hello, welcome to the second course of Artificial Intelligence from the ground up. So today we'll begin a new topic on the neural networks, where you do have multiple neurons, multiple perceptrons into one big and beautiful neural network. So I'll explain the base concepts. So here we have, for example, some inputs, 4 and 5, and there are some connections from the inputs to the first two neurons. All those blobs are neurons. So, and the entirety is a neural network. The first part, like the first layer, it's called actually like this, the first layer of the neural network. The second one is called the second layer of neural network, and the third is the third layer. And we have at the end we have the output. So we want to compute firstly the first layer of those two neurons, like in the previous course when we had a function and want to input something and then output something after a function. And we have those connections here, and those connections are numbered, are weighted. Those are called weights. Those numbers 1, 3, 3, 2. And then, yeah, those are the formulas, very simple formulas. So A will be equal with 1 times 4 and then 3 times 5 and then a plus between them. So yeah, we have 19. The same for second one. Okay, so I'll have an example here, an interactive example, so maybe we could do it together. You can pause maybe and try it yourself, or I'll do it from now if you'd like. So first of all, let's actually make it a little bit more of an example, so because you want to keep this in mind. So we do have, for example, an athlete, and we want to know at the end between with what probability this athlete would be able to compete in a national basketball or football team, whatever. So I would decide as my features, as my inputs, that I would have the weight in kilograms of the athlete, the first number of the kilogram. So for example, if you have 77 kilos, I'll put the first 7. If you have 73, I'll put still 7 because it's the first 7, and so on, and maybe the first number of the age. So I chose small numbers just so we don't get thrown off by the calculations here. So yeah, let's imagine that, just imagine we have those features 7 and 2, and based on those, basically somebody or our neural network should understand if the athlete is gonna take part in a special team or not. Alright, so the first matrix will be 1 0 1 1 1 1. Alright, so it's gonna be this first vector times this matrix, so it's gonna be 7 times 1 plus 2 times 1, so it's gonna be like a 9. Now we have 7 times 0 and 2 times 1 is gonna be like a 2. And also I have here it's a special visualization technique that I'll show you. We begin by having the first, let's say, vector 7 2. Let's say we have 7 1 2 3 4 5 6 7 and then 2. So we do have something like this. So yeah, so there are 5 plus 2, okay, here. This is the first vector. So this is the first one. So actually I'll remove this one because it's easier. So 7 times 7 2 is gonna be translated after the matrix multiplication into 9 2. And here is gonna be 9 and 2. Pretty nice, pretty nice. And in the end it's gonna be one number, which is gonna be cool at the end. Alright, so let's say we have 7 2. I'll move this one and it's gonna be moved by this matrix multiplication to 9 2. So 2 more squares. Or here, yeah. Right, one. No, there are 4 here. Okay. Here. 1, 2, 3, 4. Oh, here are 4. Okay, here. So this is 9 2. So from there to here, it's going to be transformed. And in the end, it's going to be transformed to one number. That's why I have only one axis here. So let's just, for the sake of the example, to do this, we have 9 here, and then we're going to have -9 plus 4 minus 5. I'll move this around. This is what a neural network does in its internal state. So this is the internals of neural networks. I emulate that now, so this is very good, very instructive. If you get that one, so it's 1, so this is 3 and then 2. This is 3 and then 2. Okay, so it's gonna be moved to 9 minus 5, another matrix multiplication for the last one. Let me also write it here. The results, very important, so we don't forget. And we have -5, and then we have 9 minus 5 is 4. Good. So I'm gonna write it here, -5, 4, and then I'm gonna have the x-axis -5, so we're gonna translate it here. 2, 3, 4, 5, and then 1, 2, 3, 4. Very nice. And then the last one, -1, 1. It's only 1. Basically, it's like would have would have like here -1 is gonna be -1 times 1, and then 4 minus 1, so it's gonna be -9. Great. So -9. So this is gonna be translated to the actual number here. Let's say we have the 0 number here. If I put a 0 here, I understand that's a 0. So we're gonna want this one, literally this one, is gonna be translated into 1, 2, 3, 4, another 4, and then -9. Very nice. And then this one is gonna be interpreted by us as a negative number, and therefore we're gonna say, okay, so this is a negative number. I'd say here, okay, so we have -9, and as an extra post-processing, we have another computation that says, okay, this is a negative number, so my result is gonna be -1. -1 meaning it's not gonna be accepted, or it's gonna be accepted because we have two results. I'm gonna say it, okay, I'm gonna imagine if it's 1 accepted and -1 not accepted, and I say, okay, this is not acceptable in the league. Obviously, this is only the prediction of our neural network. So I'm gonna say y hat just as a notation. Okay, y hat is -1, and then in our training data, we say, okay, we check this person and we see this person if it actually tried, we have in our data set, is it accepted or not? So we have y is equal with 1 or -1. Let's say here it's equal with 1. It's very interesting. It's equal with 1, so it's actually different. Obviously, we know from the previous lesson that, okay, now we compute the error. In the last lesson could have been something like the y hat minus y times the power of 2 for the sign. So this is really good. And then we compute the derivative of the error with respect to each parameter. So we can compute the gradient descent and then update each of those parameters. We know from the last lesson. But this would be called like the derivative of E with respect with, W. And then the W is gonna be W1, this is W1, W2, W3, W4, and so on and so forth. For example, there are models there with billions of parameters. If you know the llama models or stuff like that, we have billions of parameters, so the really big neural networks there. But yeah, this is the concept. So this is the concept called feed forward. So this is feed forward. This is what it's called because we feed the data into our model, and then we compute a probability. If you want to do a probability, we could do that, but we do a prediction of what we think could happen, and then we actually check it with our data set with the true result, with the true y. It is called the ground truth. So yeah, we compute the error, And then on the back propagation, this is called when we update all of those parameters with, I hope you remember. So it's gonna be W prime, let's say, minus this error here. This is what the gradient descent is. If you don't remember, go back to the previous video. And yeah, this is actually, yeah, it's equal with W minus derivative of that. We could put also a learning rate there called alpha. I'll put A here. So yeah, times the derivative there. So this is, yeah, the gradient descent and the update for each parameter. But very important, this is called feed forward. This is what we did today. Forward, and this feed forward, this is what it's doing in the internals of the network. Now, my question is, looks good, very nice. That's all for this course, for this lesson, but I want to ask you, what do you think is wrong with this model? Because something is wrong. And I'm gonna give you a hint on that. Those are linear transformations. This is what they are called because the only thing that is done is multiplication and addition. So I want to ask you, okay, so the more matrices we have, and the more of a transformation we have to this vector, and in the end we have -1 and 1. And what do you think is wrong? I'm gonna leave you that question and see you in the next lesson. Bye.